Hello everyone and welcome back to another video. Today we're going to be solving the LeetCode question 926, flip string to monotone increasing. Okay, so in this question we're going to be given a binary string, so zeros and ones, and it is going to be monotone increasing if it consists of some number of zeros, it could be none, followed by some number of ones, which could also be none. So you're given the string s and you can flip any of the characters from a 0 to a 1 or from a 1 to a 0. And making that flip would take a cost of 1, right? So essentially what we want to do is we want to return the minimum number of flips to make S monotone increasing. Okay, so over here I have 0, 0, 1, 1, 0. So how can I make it monotone increasing? So one thing I could do is I could convert all the zeros to 1, right? But that would take 3 changes. But that is a possible solution. Another solution would be taking both of the ones and converting that to a 0. That is also valid, but that would have a cost of 2. And finally, the best solution is I take the last 0, convert that to a 1, and that would just give me a cost of 1. And that's what I return. I return the minimum cost. Okay, so let's actually see how we can solve this question. So one common mistake that is normally made with this, and especially something even I made, is that I try to ignore the beginning and the ending. So for example, if I had a ton of zeros in the beginning, followed by some ones, right? What I would do is I would ignore these zeros and ones, assuming that they are in the correct position. But what we need to understand is that just looking at the middle is not enough information. We have to look at the entire thing at a time. Because if you just look at one certain part, we might have a solution which just includes changing these zeros to ones. So we have to look at the entire string all the time. Okay, so what I'm going to do is just to kind of replicate that, I'm going to keep coming up with a input and show you how the result would possibly change, and we'll try to come up with a solution with that. So let's say in the input right now, I'll just keep adding on to it. I'm just going to start off with 0. Okay, so currently, do I have to make any swaps? No, because it is monotone increasing. So now let's say the input is 0, 1. Is this monotone increasing? Well, it is. So the result is still 0. Now let's say I get 0, 1, 0. Okay, so this is where it gets interesting, right? Because now that I have 0, 1, 0, there's two things I could do. This is not monotone increasing, by the way. But to make it monotone increasing, I essentially have two options. I could take the 0 over here and make it 1. Actually, I have more than two options, right? I could make both of these 1, and I could make everything, but that is going to take a cost of 2. I want to have the minimum cost. So with a cost of 1, what can I do? So over here, I can convert the 0 to a 1. So that is one solution, right? So that would now give me a resultant input of 0, 1, 1. Or the other option is convert this 1 to a 0, right? So that would be 000. So now the question is, which one is better between these two? Should I have 0, 1, 1 or 000? And the answer is we don't know which one is better. At least we don't know which one is better yet, right? And we know which one is better as we move further on, right? So my best example for that is, let's say I have a 0 or if I have a 1 here, the answer to that is going to completely change. And I'll show you that, okay? So we actually don't know which one is better, but we do know one thing, which is no matter what which operation we choose, we're going to have a change of 1, right? So there is going to be a change. Either is it over here or over here, we don't know that yet. So the result is going to get incremented by 1. And that is what is important because all we care about is the number of steps it takes. Okay, so the result is incremented by 1, but again, we don't know which one it is yet. So let's try to find out how we come to this conclusion, okay? So now let's say the next number is a 0. Okay, so in this case, what exactly is going to happen? So what could I have? So I could either have 0, 1, 1 so far, right? So what I'm going to assume is that everything so far is monotonically increasing, right? So I could either have 0, 1, 1 or 000 and now have added this extra 0 over here. So if this was the case, right, and I have all 4 zeros, it is already monotonic increasing. I don't have to have any extra changes. So in that case, the result stays as 1. But if this is what happened, and I had 0, 1, 1, I would end up with a result of 0, 1, 1, 0. And I could change that to make it monotonic increasing by making the 0 a 1. But in this case, I would have an additional cost of 1. So in this case, the result would be 2. Okay, so this is essentially what we're trying to understand. How do I know which option is the best for me? Is it this or is it this? And to do that, what we're going to do is we're going to keep track of the number of ones we have. Okay, and I'll try to explain that better. So the number of ones so far. Okay, so how many ones have we encountered so far? Well, we've only encountered one. Okay, and essentially, I'm just going to break it down a bit more. All we're really looking at, so this is only in the case when we have a 0. Okay, so I'm going to be very clear. Whatever I'm saying right now is when we encounter a 0. Okay, so when we encounter a 0, one of two things can happen. Either the 0 over here stays as 0, obviously, or it becomes a 1. And if it becomes a 1, we have to add 1 to the result. Okay, so let's try to break this down, right? So if the 0 becomes a 1, what happens? So the result increases by 1. But if the 0 stays at 0, what is the clause that I have? Okay, and the idea is very simple. If this 0 wants to stay as a 0, everything previous to that must also be 0. That is the basic definition of being monotonically increasing. So if this wants to stay a 0, everything prior to it must be 0. And another way of saying that is that all of the ones before it have to be 0 no matter what, right? And that is nothing else but keeping track of the number of ones we have. So if this wants to stay 0, the cost would just be the number of ones, okay? So just to break it down even more, at each step, right, we're deciding two things. Do I make it a 1 and increase the cost by 1? So the new cost is res plus 1. Or do I make everything prior to it, all the ones prior to it, a 0? And that would have a cost of the number of ones. So essentially, I am choosing between these two options. And to be even more specific, I am going to choose the minimum of these two because my goal is to minimize our cost. Okay, so that is exactly what we're going to be doing. So let me just show you what that looks like, right? So right now I have, let's say in the beginning, let's just start off. The count would both be 0, 0, right? So now I came across a 1. So the number of ones I have is now incremented. Now I came across a 0. Okay, so essentially, if I have a 0, my condition is simple. I choose the minimum between taking the 0 and making it a 1 or choosing the number of ones, which is the same as making sure that everything before it, all the ones have become zeros. So in this case, which one is lesser? Well, they're both the same. Okay, so in that case, the result is now going to be 1. Now again, we don't know which of these two has happened. And the thing is, it doesn't matter so far, right? We just know that one extra operation has happened. So now let's say I add the 0 over here. Now what is going to happen is the same thing, right? So over here, I do the same thing, and that is I check. So I can either convert this to a 1, right? So that would now, what would that look like? That would look like 0, 1, 1, 1. I could either have that, or I could convert all the stuff before it, so all the ones to a 0. Now, which one is lesser? Sorry. So obviously 1 is lesser than 2, right? So in this case, essentially what I'm saying is the option I am choosing is this one over here. So now my result is going to stay as 1. So let's say now I have the number 1. Okay, so now the count is going to become 2. Let's say the input has 2 more ones, so now the count becomes 3, and then it becomes 4. But essentially what I want you to realize is, so let's just say else, right? Over here, each time all I'm doing over here is I'm incrementing the number of ones by 1, right? But I'm not going to make any changes because just think of it, right? If the ending is all ones, that is completely fine. It is monotonically increasing. But the problem comes is if I have a 0 after it. So now if I have a 0 after it, which in this case is a problem. So I go back to this if condition and I look at my options. This 0 over here can either stay as a 0, and if it stays as a 0, all the ones before it have to become 0, right? So the cost is the number of ones, or I could just make the 0 a 1, and I would do that by increasing the result by 1. And in this case, which one is lesser? Well, is it 4 or 1 plus 1, 2? Well, 2 is lesser. So this result is 2. And really what I have is I now have 0. This 1 became a 0, 2 more zeros, and triple 1. And the last 0 became a 1. So this is the result I really came up with. So hopefully the solution does make sense. And the code is really this. That's it, essentially. So I'm just going to show you what that looks like as well. So it's really straightforward. It's the exact same thing that I explained. Oh. Okay, yeah. So I keep track of a result and the number of ones, which I called count 1. And I have a for loop, so which goes through each of the characters. So if the character is equal to 0, then in that case, I either convert that 0 to a 1, or I convert all the ones to a 0. So whatever the minimum cost is, that is what I am choosing, okay? Now, if this is not the case, it means it's a 1, so I just increment the count by 1. And in the ending, I just return the result. Okay, so if you submit the solution, it is going to get accepted. So that should be it from my side. And thanks a lot for watching, guys.